Welcome everyone. Now we are going to start a new topic which is a refraction at spherical surfaces and by lenses. For class 12 physics, ray optics chapter name, and this is an important topic for the CBSE, NEET, IIT JEE. So let's begin. I'm host your Sapna Soni. I'm physics expert faculty. Now taking the first topic which is lens. A lens, that means a thin lens is a transparent optical medium bounded by two surfaces, at least one of which should be spherical. Convex lenses are a converging type of a lens, whereas concave lenses are a diverging types of a lens. So here I just want to elaborate the meaning of a converging, which is a meeting at a particular point. Meet at a point or focusing. Like as you can see over there, this is a point where all the light rays are converged at this point. We are called as a focus, or like what we are doing. We have a different kind of a knowledge, but when the exam came, we are just preparing one by one the subjects. So we are focusing on the subject because the target is only one. Understood? So all the light rays start and meets at a particular point. So we are trying as a conversing and diverging. At a particular point, if the light rays are continuously emerging like this, so we are saying as a diverse. Conversing lenses. Biconvex lens, equiconvex lens, planoconvex lens, convexo-concave lens. These are the conversing lens. Now I'm just elaborating one by one these lenses. Biconvex lens, they have two faces, two curved faces, two curved faces. Again, equiconvex lens, they have also two curved faces, equal faces. Equal means, as you can see, if I'm just making an axis, so they are geometrically equal in nature, but this is a knot. Okay, as you can see over there, this is not actually equal. This is a plano-convex lens. One side is a plane, other side is a convex. So this is we are saying as a plano-convex. Convex or concave, where both side is a convex. This is also convex, this is also convex. So we are saying convex or concave. Okay, this side is a concave. So this is side is called as a convexo-concave. Means one face is a convex and the other is a concave. So generally convex, you have to term like that, convex only. Okay, convex. So these are conversing lens. Okay, conversing lens. How you remember? So there I have a trick for you students for remembering conversing. As you see, converse or convex. Okay, so till here, as you can see, more terms are coming here. In a concave, this will be concave. Okay, that V is a knot over there, like words. In this convex, VE also words. Okay, that means converse, concave, converse. Clear? But concave is different, like look like that. They have a long sentence, so they will diverge. Okay. Again, biconvex concave lens. So they are not geometrically equal. They are geometrically equal. One side is a plane, other side is a concave, next concave, another side is a convex. So we are saying as a concave convex. Refraction at a spherical surface. So here we have making a spherical surface. For memorization, you can see like this is a what? This is a convex. Okay, this is a convex mirror. But here we are taking convex surfaces. So we are taking what we have taken convex surface, convex spherical surface or convex spherical lenses. Okay. From here, I'll just send an incident ray. This is what? Incident ray. And this is a normal. From normal, it will making an angle alpha. Similarly, normal is a point. We got a point where the light rays reflect. Okay. So what we are assuming, this is a particular point. Okay. Where the light rays again move in its or retracing its own path. So that is C. From this particular angle like C, this will be making an angle beta from this normal. And here, if I'll just back the light rays, this light rays, so like light rays after refraction, because what we know, when the light rays passes from the rare medium to denser medium, it will bend towards the normal. So this is a normal and light rays actually wants to go here, but because of this medium changement, it will bend towards the normal. So when I like change this light rays, it will be makes an image which is I. From this normal, it will be making an angle gamma. So from exterior angle theorem, we can say consider an object O on the principal axis of a spherical surface. C is the center of a curvature over here. R is the radius of a curvature and I is the image. O is an object. The rays are incident from a medium of a refractive index N1 to other refractive index N2. From figure, as you can see that angles are too much small, alpha with the beta and gamma also. So tan alpha we can say assume as a alpha, which is a mn by om, and tan beta mn by mc, and tan gamma mn by mi. So from here, as you can see exterior angle theorem, this, as you can see, this is a triangle and two interior angle equals from their exterior angle. So internal angles, two angles are must be equal from the external one. So I is equals to alpha plus beta. I hope you understand how I can write, how I actually write. Similarly R, as you can see over there, if I'm just taking this angle. So R plus gamma is equals to beta. We can write as a R is equals to beta minus gamma. Understood how I written over there here? By Snell's law, n sin I is equals to n2 sin R. From a small angle, n1I is equals to n2R. We just put this value for alpha, beta and gamma. We got an equation n1 by OM plus n2 by MI is equals to n2 minus n1 by MC. Here OM, MI and MC represent magnitude of a distance applying a certain sign convention. OM is equals to minus U, MI is equals to plus V and MC is equals to plus R. Substituting these in equation 1, we got n2 by v minus n1 by u plus is equals to n2 minus n1 by r. So this is the relation between the object and image distance in the term of refractive index of the medium and the radius of a curvature of the curved surfaces. It hold goods for any curved or spherical surfaces. So refraction by a lens maker's formula. Refraction by lens maker's formula or lens formula. In case of an image formation by lens, it can be seen in terms of two steps. The first refracting surface forms the image I1 on object O. The image I1 acts as a virtual object for the second surface that forms the image. Like if I have just taken a lens, this is a equiconvex lens, and light rays are incident in two ways. First, by the principal axis, which move straight because they are passing from the optical center without any deviation, they just passed away. And one is if I'm just sending through a particular angle of a lens. So they will again, because of refraction, they will bend. The position of an object and image formed by the double convex lens. Like this. Refraction at the first spherical surface, and this is the refraction by the second spherical surface. From both the surfaces, images are formed and two steps. Like the first refracting surface image is I1 on O, and the second I1 virtual surface formed at I. So the first interface ABC, we get this value, and for the second interface we get this value. Adding both the equation, we receive this term, and by sign convention OV is equals to minus U, DI is equals to V, and BC is equals to R1, CD is equals to R2. Equation becomes N1 by minus U plus N2 by V is equals to N2 minus N1, 1 plus R, 1 by R1 plus 1 by R2. The object is at infinity, that is U is equals to infinite, V is equals to F. Equation 4 becomes 1 by F is equals to N2 minus N1, 1 by R1 minus 1 by R2. This is the fifth equation. This is known as a lens maker formula. Students, this is an important formula for the NEET examination, for the boards also, very important. Like 2016, 17, 19, also 22, many questions asked in this. From 4th and 5th, 1 by F is equals to 1 by V minus 1 by U. So this formula is valid for both, for the convex as well as for the concave lenses, both real and virtual images. Now let's move on to some questions. Dash are the converging lens. Concave, convex, biconvex, both B and C. The correct answer is both B and C. Second question, dash are the diverging lens. Concave lens, convex lens, biconcave lens, both A and C. The correct answer is D, both A and C. 1 by F is equals to N2 minus N1, 1 by R1 minus 1 by R2 is known as a lens formula, lens maker's formula, both A and B, and none of these. The correct answer is a lens maker formula. This is not a lens formula, this is a lens maker formula. Lens formula, then what? Then lens formula is 1 by F is equals to 1 by V minus 1 by U. Power of a lens. From this topic, again, many questions asked from the board examination, NEET examination, as well as for the IIT JEE examination. Okay. So moving, power of the lens. It is represented as a P. It is a measure the convergence or divergence which is a lens produced or introduced in the light falling on it. Power P. The tangent of an angle by which a lens converges or diverges a beam of light falling at a distance from the optical center. The reciprocal of a focal length is called power. So tan, like if I'll just take in a lens, light rays are going this side and makes an angle chronicle delta. So chronicle delta tan chronicle delta h by f. If height of the image, height of the lens is h, I'm just assuming. So P is equals to 1 by f. This is the SI unit of power. Is the diopter. 1 diopter is equals to 1 meter. The reciprocal of focal length is of a lens is called diopter. Combination of a thin lenses in contact. Consider two lenses A and B, focal length f1 and f2 placed in the contact with each other. O in an object beyond the focus of the first lens. For this scenario, first lens produces an image I1 and I1 is a real. It behaves as a vertical object for the second lens, produces the final image I. For the image formation formed by the first lens at A, which is 1 by V1 minus 1 by U is equals to 1 by F1. For image formed by the second lens B, 1 by V is minus 1 by V1 is equals to 1 by F2. Equation 1 plus 2 gives the equation 1 by V minus 1 by U is equals to 1 by F1 plus 1 by F2. If two lenses system are regarded as equivalent to the single lens of the focal length f1, we have 1 by v minus 1 by u is equals to 1 by f. From equation 3rd and 4th, we get the relation 1 by f is equals to 1 by f1 plus 1 by f2. For more number of lens, we have formula 1 by f1 plus 1 by f2 plus 1 by f3. Student, I hope you are understanding how we will get this formula. Now, in terms of a power, this will be power P is equals to P1 plus P2 plus P3 up to Pn, wherever the numbers actually have. And the total magnification, M is equals to M1 plus M2 plus M3. Now, the questions are the unit of power of lens is called meter, diopter, candela, centimeter. The correct answer for this question is diopter. The measure of a convergence of and or divergence is called as a lens. Focal length, angle of deflection, power, angle of refraction. Answer is the power. So students, this is all for today's class. I hope you understand a lot of the things and grabbing more and more concept. So take care everyone and thank you for watching this video.